Hi everyone. In today's lesson we're going to be looking at piecewise functions and how to graph them. So in your notebook, please put down today's subtitle, which is Graphing Piecewise Functions. Fortunately, when it comes to graphing piecewise functions, it's extremely hands-on and does not involve much theory. So let's get straight to it. First, we're going to start drawing a very easy piecewise function that involves only two different pieces. In this example, we'll be drawing f of x equals to 2 when the domain is less than or equal to minus 1, and f of x is equal to negative 3x if the domain is from minus 1 to 2, not including the minus 1, but including the 2. In order to fit the graph of this piecewise function nicely, we're going to need a grid that's about this size. So go ahead, pause the video, and prepare your grid. Let's begin by first drawing the first piece of the function. F of x is equal to 2 as long as x is less than or equal to minus 1. As you can probably recognize, this is a constant function. When drawn properly, this piece should look like the following. Notice the coordinate at negative 1 and 2 is a closed point because when x is equal to negative 1, it is included. Next, let's draw the second piece of the function. The f of x is equal to negative 3x as long as x goes from negative 1, not included, all the way to positive 2, included. You should realize immediately that this is a linear function. So you can rely on your skills of drawing linear functions, or here's an alternative. Probably the most efficient way to draw this linear function is to simply plug in the two limits of the x values into the function. Because when x is negative 1, this is where the line starts, and when x is positive 2, this is where the line ends. And as we all know, the easiest way to draw a straight line is to simply get 2 points and then connect those 2 points. So let's calculate what this function equals to when x is negative 1. So f at negative 1 is equal to negative 3 times negative 1, which is equal to positive 3. Now let's also calculate what will be the value when x is 2. So when x is 2, we get negative 3 multiplied by 2, which equals to negative 6. So we know that this linear function will begin at the point negative 1 and 3, and will end at the point 2 and negative 6. So let's get those coordinates down. For the first coordinate, the beginning of the line, negative 1 and 3, keep in mind that this will be an open point because the domain doesn't actually include the negative 1. So at negative 1 and 3, we should find an open point. And for the end of this line, located at 2 and negative 6, it should be a closed point because in the domain, the 2 is included. So 2 and negative 6. And then just finish up the line. And there we have it. This is the graph of this particular piecewise function, which consists of the two pieces. Over here, y equals 2, and over here, y equals negative 3x. Okay, let's try drawing a more complicated piecewise function that involves 3 different pieces. For your next example, please get the following piecewise function down. The piecewise function f of x consists of 3 pieces. F of x equals to 3 as long as x is less than or equal to negative 1, or f of x is equal to 2x minus 2 as long as x goes from minus 1 to positive 2, excluding the minus 1 and the 2. And finally, f of x is equal to x squared as long as x is bigger than or equal to 2. So we have a three-piece piecewise function. For this example, in order to accommodate the graph decently, we're going to need a grid that's about this size. So go ahead, pause the video, and prepare your grid now. Let's begin by drawing the first piece. The f of x is equal to 3 as long as x is less than or equal to negative 1. This is another constant function, and it will remain constant until x reaches negative 1. When drawn properly, this constant function should look like the following. Next, let's draw the second piece. The f of x is equal to 2x minus 2 as long as x goes from minus 1 to 2, excluding minus 1 and excluding 2. This is another linear function. So, again, you can either rely on your previous skills on drawing linear functions, or the most efficient method is to simply figure out where the line starts. So when x is negative 1, and where does the line end? So when x is positive 2. So let's find those start and end points. When x is negative 1, we get 2 multiplied by negative 1 minus 2, and that gives us a y value of negative 4. Let's figure out where this line ends. So when x is positive 2, the function gives us 2 multiplied by positive 2, subtract 2, and that gives us a y value of 2. So this line will start at the point negative 1, negative 4, and will end at the point positive 2, positive 2. And keep in mind that they are both open points, because the x values of negative 1 and positive 2 are not actually included in the domain. So let's get those coordinates down. First, negative 1 and negative 4. So that should put it around there. And then the positive 2 and positive 2, which puts it around there. And then, of course, connect those 2 points with the line. And finally, let's draw the third piece. The f of x is equal to x squared as long as x is bigger than or equal to 2. You should recognize this as being a quadratic function, which means that it's going to end up being a parabola. Now, given the limited height of the grid that we prepared, we won't see much of the parabola. However, if you wanted to, you can extend the height of the grid in order to show more of the parabola. To draw the parabola, you can either rely on your previously learned skills in drawing parabolas, or more efficiently, simply figure out what is a y value when x is 2, because in this interval, this is where the parabola starts. And if there was an endpoint, you can calculate where it ends, and then you have your parabola. In this particular case, this parabola never ends. So we'll just figure out where it starts, and then try to approximate a decent parabola from there. So let's figure out at what coordinate it starts. When x is 2, the y value gives us 2 squared, which is equal to 4. So this piece of the piecewise function will begin at 2 and 4. And it will begin with a closed point, because when x is 2, it is included in the domain. So it starts at 2 and 4. And if you wanted a second point to try and give a more decent parabola, you're free to do so. I'm just going to approximate it to something like this. And this is the graph of the piecewise function, consisting of the 3 pieces. The y equals 3, the y equals 2x minus 2, and finally the y equals x squared. And that's all there is, ladies and gentlemen, to drawing piecewise functions. As you can see, it is not terribly difficult. All you have to do is go slowly and carefully while respecting the different domains of the different pieces.